Hello everyone, welcome to my channel. In this video we will talk about D flip-flop. So flip-flop is also called as 1-bit memory cell because it can store 1 bit of information, and that 1 bit of information can be either 1 or 0. D flip-flop is sometimes called as data flip-flop or delay flip-flop, and this is also called as transparent latch or transparent flip-flop. Reason is whichever value we apply at D input comes at the output side, and that is why it is called as transparent switch. So let's draw the symbol of D flip-flop. As this is flip-flop, it has one clock input. So this is my clock. Another input is D input and it has two outputs, Q and Q bar. This is my D flip-flop. So it has only one input D input, it has clock, it has output Q and Q bar. Now let's write truth table of this D flip-flop. Truth table is it has only one input, so one input D and output is Q N. If input is only 1, it means there are only two conditions possible, 0 and 1. So in this transparent flip-flop, whichever data is present at the input side comes at the output side. So if data input is 0, output is 0. If data input is 1, then output is 1. So this is truth table. Now let's write the excitation. Okay, before excitation table, let's go for characteristic table. So in characteristic table, we consider the inputs and we also consider the present value of output. And based on that, we try to identify the next value. So D is my input, Qn is my present output. I have some output right now. So I need to identify what my next output will be. So here there are two variables. So conditions are 0, 0, 1, 1, 0, 1, 0, 1. It means either 0, 0, 0, 1, 1, 0 and 1, 1 are the possible conditions. But in D flip-flop, it is very simple. The data present at the input comes at the output side. So here output will be data input is 0, so output will be 0. Data input is 0, so output will be 0. Data input is 1, so output is 1. Data input is 1, so output is 1. So we don't even look at the value of present output. Present output doesn't matter. Only input matters. So this is characteristic table. From this characteristic table, we can write the characteristic equation. So Qn plus 1 is equals to simply D. Of course, the data input comes at the output side. So this is characteristic equation. Now let's write the excitation table. Excitation table basically tells us I have this output now. I want this output after some time. What input I should apply? So excitation table tells us, or it tells us the values of outputs and it asks us to predict the value of input. So present output is Qn, next state output is Qn plus 1. So conditions are again 0, 0, 1, 1, 0, 1, 0, 1. So these are the outputs which I want. So if I want 0, I should apply 0. If I want 1, I should apply 1. I want 0, so I should apply 0. I want 1, so I should apply 1. This is one way. Other way is, here you can compare. See, Q is 0, Qn plus 1 is 0. So D is 0. So this is the condition. When Qn is 0, Qn plus 1 0, then D must be 0. Next, Q is 0, Qn plus 1 is 1. So 0, 1. At that time, data is 1. So here it is 1. So generally, when we write excitation table, we write it from the characteristic table. So this is excitation table for D flip-flop. Now let's draw the diagram for D flip-flop using NAND gates. This is the diagram of SR flip-flop. So in case of SR flip-flop, by connecting inverter or NOT gate between two inputs, we can make it as D flip-flop. Or simply, if you want to make D flip-flop from JK flip-flop, then what you need to do is, JK flip-flop is similar to SR flip-flop, only the difference is there is a feedback. So in this way, simply by connecting inverter between two inputs of SR flip-flop or JK flip-flop, and this is our clock input. This is our clock. We can convert SR or JK into D flip-flop. See, I have prepared separate video for conversion of JK flip-flop into D flip-flop. In that, every single detail is explained, that how to convert, why the inverter is needed, K-maps, everything is explained. Here, if question is explain D flip-flop, then you just need to explain these things. No need to explain how to convert SR into D. You just need to know that there is an inverter present between two inputs. So D flip-flop, symbol of D flip-flop, truth table of D flip-flop, characteristic table of D flip-flop, excitation table, and this is the diagram of D flip-flop using NAND gates. Now let's see how this circuit works. So if my data input is equals to 0, because of this inverter, here what I'll get 1, and clock is already connected, so we'll assume clock is 1. So because of this 0, in case of NAND gate, if any one input is 0, output is 1. So here we will get 1, and because here 1, 1, and let's assume Q is also 1. So here what we will get? 0, 1, 0. So in SR latch, this is our SR latch. So here we will get, in case of SR latch, when inputs are 1, 0, output is equals to 0. Similarly, for 1, if I'll apply 1 here, then here what will come? 0. Because of this 0, we'll get 1 here, and because here we will get, in case of NAND gate, both inputs are 1, and we'll assume the third input is also 1. So here will come 0. So for 0, 1, we'll get output 1. So whichever value we apply at the input side, we are getting same value at the output side. In this way, this D flip-flop works. Thank you so much for watching this video. Please subscribe to my channel, share this video with your friends, and press the bell icon so that you will get notification of newly uploaded videos. Thank you so much.